In your packets, lesson 7.1, day 2. And I do not believe there is a separate title page in your packet, right? So we're on page 9, very top of page 9. Yes, good. All right. So go ahead and try these two. It would be a good review. Factoring out the greatest common factor for x cubed plus 5x squared minus 22x, and 18x to the 4th plus 6x cubed plus 24x squared. I'll give you a minute or two. Go ahead and factor those, and we'll take a look at the answers. All right. For the first one, a couple of things. First of all, make sure your expression is written in standard form before you start factoring. If it's in standard form, you will know that you have a variable for your greatest common factor if there's a variable in the last term. Not only will you know if your greatest common factor has a variable, you'll also know exactly what it is. So x to the 1st is going to be part of our greatest common factor. Then we need to check, do we have a number that's the greatest common factor? So if we look at our coefficients, we have a 1, a 5, and a 22, sorry, 1, 5, and 22. Is there a number other than 1 that evenly divides into 1, 5, and 22? Because one of our coefficients is 1, that kind of limits our GCF. So this one does not have a number factor for its GCF. It just has the x. Then we are going to rewrite inside of parentheses what we would have left. And so we had x to the 3rd. We factored out one of the x's, so we're left with x to the 2nd, or x squared. We didn't have a number for our greatest common factor, so we keep the 5. We had x squared. We factor out an x. We're left with x to the 1st power, or just x. The last term we have had negative 22 times x to the 1st. We factored out that x, so we don't have an x in that term. And there would be our factored out version of that expression. It's also a good idea to write this in standard form, because if we have a variable in that last term, we missed something in our greatest common factor. There should be no variables ever when we're factoring out a greatest common factor, there should never be a variable in that last term. Example 2. Is there going to be a variable part for our greatest common factor? Are there variables in every term? In standard form, so we know our last term, that x squared, is going to be part of our greatest common factor. Then we check 18, 6, and 24. Is there a number that evenly divides into 18, 6, and 24? And we could take the smallest number, the 6, and look at its factor pairs. 1 and 6, 2 and 3. And then check. Does 6 divide evenly into 18? Yes. Does 6 divide evenly into 24? So that's our greatest common factor. Going to have a 6. Writing what's left over when we factor out 6x squared, we take 18 divided by 6. What is 18 divided by 6? 3. We had x to the 4th. We factored out an x squared. How many x's do we have left? 2. X squared plus 6 divided by 6. 1. We had x cubed. We factored out 2 of the x's. We're left with x to the 1st. You could put the 1 in front if you wanted. You don't have to. 24 divided by 6. 4. We had x squared. We factored out x squared. So we don't have any x's to put in that expression. So the factored form 6x squared times the quantity 3x squared plus x plus 4. Number 3. What is the smallest exponent on the variables for number 3? The smallest exponent is on that last term. It's an x squared. Again, looking at the coefficients, the number in front, if I look at the smallest number in front, 3, and the factor pairs for 3, it's a long list. So pay attention, right? 1 and 3, and that's it. So I want to check my other coefficients and see if they're evenly divisible by 3. Always start with the largest factor. So is 9 evenly divisible by 3? Yes. Is 12 evenly divisible by 3? Yes. So 3 is going to be part of our greatest common factor. So my first term in the parentheses, I take 3 divided by 3. What's 3 divided by 3? 1. I had x to the 4th. I factored out x squared. That leaves me with x to the 2nd, or x squared. 9 divided by 3. 3. I had x to the third power. I factored out 2 x's, and I'm very careful which 2 x's I factored out. I think you've noticed that already, right? And how many x's do I have left? 1. 12 divided by 3. 4. I had x squared, but I factored out, so there are no x's with that one. All right, last example here. Are there variables in each term? Actually, we should check first, is it in standard form? Again, I always like it in standard form because I can look at the last term for my greatest common factor for my variables. Is this in standard form? Largest exponent down to smallest for my variables? Yes. So I know x has got to be part of my greatest common factor. What's my smallest coefficient? 5. And if I look at the factor pairs for 5, that would be 1 and 5. So I'm going to check, does 5 evenly divide into 35? Yep, right? The rule for dividing by 5, it has to end in a 5 or a 0. So it works here. Does 5 divide evenly into 50? Yep. So 5 is also part of my greatest common factor. 5 divided by 5. 1. I had x to the 5th, and I factored out an x, leaves me with x to the 4th. 35 divided by 5. 7. I had x to the 3rd. I factored out an x. I'm left with x to the 2nd. 50 divided by 5. 10. And I factored the x out. All right. Questions on those? So another way that we can factor greatest common factors is using something called an area model. It's basically the box method, but we're working backward. So if we have the expression 45x squared plus 20x, we want to find the greatest common factor. And we're going to write the greatest common factor out front. And then what we've written in parentheses to this point, we're going to write, I'm going to write it at the bottom because I have those question marks on the top, but we would normally write them across the top. So, is there a number that evenly divides into 45 and 20? How much? 5? I like 5. Do I have a variable in that expression that I can factor out? Yep, there's an x in both. So now I divide. 45 divided by 5. 9. I had x squared. I factored out an x. I'm left with x. 20 divided by 5. I had an x, but I factored it out. Okay, right back. back there. Go grab it. Put your mirror away and time to do some math. So there would be, if I factored it in the way I did the last example, it would be 5x and then in parentheses 9x plus 4. This one, the line isn't written in the middle, which I actually prefer that it's not written there. It just gets in the way. 9w to the third minus 12w squared. Is there going to be a w in my greatest common factor? Yes. W to what power? W to the second power. As far as the greatest common factor for my numbers, now, is it helpful for you to write out the factor pairs? So if I write out the factor pairs again, normally I look at the smaller numbers, so I would look at the 9, and 9 has factor pairs 1 and 9, 3 and 3, and that's it. So check the largest factor, 9. Is 12 evenly divisible by 9? No. So then I check the next larger one, 3. Is 12 evenly divisible by 3? Yes. So there's going to be a 3 in my factor pairs, or my greatest common factor. What is 9 divided by 3? Right. Part of our factor pair, right? It's 3. I had w to the third. I took out 2 of the w's. I'm left with just w or w to the first power. 12 divided by 3. 4. And again, I had the w squared, but I factored it out. Questions there? So far, so good. I believe on the homework that you had on Wednesday, excuse me, we had a couple like this with more than one variable. So the rule is the same. I look at my x's. Do I have x's in both terms? Yes. What is my smallest exponent on my x's? Right? 1, right? It's not written there, so if we write it in, it's helpful. So I'm going to have an x, or x to the first, as part of my greatest common factor. Do I have y's in both terms? Yes. What is the smallest exponent on my y's? 1. So I'm going to have a y in my greatest common factor. The last thing, I check the numbers now. 3, we've already written the factor pairs, just 1 and 3. Is 12 evenly divisible by 3? Yes. So 3 is part of our greatest common factor. 3 divided by 3. 1. I had x cubed. I factored out one of the x's. How many x's do I have left? Had 3, factored one out. I have 2 left. I had a y, but I factored it out so that it won't be a y in the parentheses in that term. 12 divided by 3. 4. I had an x, but I factored it out. I have y cubed, but I factored out one of the y's. leaves me with y to the second. All right, I should leave that one up there. Okay on that one. Makes sense. Move to the next one. 50a squared minus 32ab squared. Do I have an a in both terms of my original expression? Yes. Smallest exponent for a? 1. So I'm going to have a as part of a greatest common factor. Do I have b's in both? No. So I'm not going to have a b in my greatest common factor. The last thing I need to check is there a number that divides evenly into both? So to check my numbers, I could do factor pairs. 32 has a lot of factor pairs. 50, not quite as many, but it also has quite a few. Is there a number that you know right away divides evenly into both? How many? 2. So let's just try 2 as our greatest common factor, and then we'll adjust it if we need to. Yeah, both numbers are even, so 2 is going to be a factor. That's awesome. What is 50 divided by 2? 25. I had a squared, factored out one of the a's. I'm left with a or a to the first. 32 divided by 2. 16. Ooh. Try to write that a little better. I factored out the a, and there was no b to factor out, so b squared stays. Now, we should check, because we just said 2 and tried it. Is there a number that evenly divides into both 25 and 16? 25, the only numbers that divide evenly into 25 are 1, 5, and 25. The only numbers of those 3 that divide evenly into 16 is just 1. So our greatest common factor of 2a was good. It was a great guess, and it worked out well. All right, bottom of the page. There is this wonderful try now. Go ahead and see if you can factor out 35, or factor completely. 35 x squared y to the 4th minus 28 x y to the 5th. As soon as one of the passes we got. So you can do it right in the notes in this. I checked it on Thursday. All right. I'll keep my hand and then. All right. Least number of x's in any of my terms. X to the first. Least number of y's. Yeah, y to the fourth. A lot of y's there. 25 and 38. Is there a number that evenly divides into both 35 and 28? I think I said 25 and 28. Did I say 25 and 38? That's even worse. 35 and 28. If we don't know, we can check, right? 28 is the smaller number. If we just start writing factor pairs, 28 and 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, and that's it. Does 28 evenly divide into 35? Does 14 evenly divide into 35? Does 7 evenly divide into 35? Yeah, so 7. And again, I always start from the largest and work my way down because we want the greatest common factor. 35 divided by 7. Five. I had x squared, but I factored out one of the x's. So I'm left with just x to the first. I had y to the fourth. I factored out y to the fourth. So I don't have any y in that first term. Minus 28 divided by 7. 4. I had an x, but I factored it out. I had y to the fifth. I took out 4 of those y's. Leaves me with 1, just y. All right, questions? All right, on your homework, problems 1 and 2 are multiple choice. Select the correct answer. 3, 4, 5, and 6. Factor out the GCF from each polynomial. Your factored form should include the GCF and what's left after you factored out the GCF. So with the parentheses and the remainder of the stuff in the parentheses, just like all of our problems on our notes today. 7 is an area problem similar to the one we did in the 2 we did in notes. If you want, you can certainly put an addition symbol in between the 21w to the fourth and the 35w squared. I prefer to have it that way. Similar problem with number 8, just not drawn with the rectangle.